Hey guys, for this video, make sure that you have already gone. The sub may need to pause this right now. Make sure that you have gone to 3D Game Lab and you have opened up your quest called Discovering Properties of the Special Quadrilaterals, and click on this hyperlink here to get the Geogebra app so that you can kind of mess around while I'm talking about how I want you to go about this quest. Okay? So this video is intended for you to watch it on Friday as a class, and then also on Monday when you come back from Christmas break, you're going to continue on this quest. So I also am thinking this video will be watched by some kids on Monday after Christmas break too. But you should have these papers. So if you're here on Friday, you're going to get these papers from the sub, and they look like this. Okay, so the first page is just this chart here that has our special quadrilaterals across the top, and then these are the properties that I want you to investigate for each special quad. And if this is a property in the special quadrilateral, you can give it a yes or a no or check it or something like that. But if it's not, you can give it an X or don't fill it out or whatever you want to do to distinguish. What you're going to make is a chart. So as you go down the special quad with your marks, you can see the properties of the special quad, which ones are true in each quadrilateral. Okay, and then when you're done with that, I just wanted you to write them out so that we have two ways of seeing the properties, through a chart, and then also use the chart to fill out these. So for a parallelogram or rectangle, as I'm looking at this, I got this from the internet. As I'm looking, I'm going to probably change the names of some things here, but it's going to be this worksheet. Fill them out, and then you're going to submit that. Or excuse me, you're not going to submit that. But what you're going to do for the quest, though, so you're going to fill out the worksheet, and then for the quest, you're going to be doing some more screen captures, screenshots here. So you're going to, every time that you use the special quadrilateral tool to make a special quad and measure the diagonals and the interior angles, central angles, and side lengths. You're going to measure those for each special quad. So when you have them all measured, take a picture of it, and then maybe through a Word document, give me a picture of each of these special quads after you have investigated the properties. Okay? So fill out the sheets here and then submit the screenshots through 3D Game Lab. Alright? So this is going to be how you use the app here. Alright. One of the main reasons that we talk about special quadrilaterals is not only can you know what they are and be able to identify special quads, because we see them in design. There's some nice symmetry to them, so whenever we reflect, remember that creates a line of symmetry or reflectional symmetry. If we rotate, there's a nice rotational symmetry. So if you look at these special quads, they have nice symmetry in them. So not only is that important, but we're going to use the symmetry to actually talk about other properties. So how we can construct these quadrilaterals in ways and argue that they're special quadrilaterals in ways that's not always tied to the definition, but other things that are always going to be the same and are specific to these special quads. Also looking at properties that are the same amongst the special quadrilaterals as well, so we can see some commonality between them. Okay, so just wanted to make sure you've seen this chart. You should have it written down. Again, if you don't, make sure you have this. It'll make your life easier. The definitions are what makes a shape. They are, if a shape has these features, then they are guaranteed. They are a parallelogram or a rectangle or a square. Those are definitions. Properties are other relationships within the special quadrilaterals that are always true, and that'll always kind of help us as well. Not only definitions, but other things that are always true. One way to illustrate that, we know that in a rectangle, like if this quadrilateral down here is a rectangle, it has four 90-degree angles, right? It's a quadrilateral, hence the four sides, and it has four 90-degree angles. So by definition, if you looked at this, we know that's a rectangle because by definition, and this again, listen to the way I talk, it helps us with proof and logic and organizing our thought. We know this is a rectangle because, right here comes the reason, it has 4 right angles, and by definition, it must be a rectangle. Okay. Now, other properties, we know that in rectangles that the opposite sides are congruent to each other, right? That's a property of a rectangle. It's not the definition. It's a property of, and these two sides, so opposite sides are congruent to each other. Okay. So that is a property of a rectangle. So I just wanted to illustrate the difference between properties, definitions. The 4 90-degree angles and the quadrilateral facts make it, define it to be a rectangle. But we also know that within rectangles that we have this opposite sides are congruent to each other relationship. Okay, so let's go ahead and discover some other properties, and we'll go ahead and write. So I'm going to just put a sheet here. We'll start with rectangles since we just looked at it. I'm just going to title these pages by the special quad. Maybe we'll go squares next, because squares are rectangles. Squares are also rhombuses, so maybe we'll say a rhombus, and we'll label our properties as we see them and write them down as we go. Alright, so we did rectangle, square, rhombus. Let's talk about kites. So in a kite, how about a trapezoid? Slash, and I'll do both on here, isosceles trapezoids too. So I'll define trapezoid properties, isosceles trapezoids, so we can sort them out amongst each other. And then let's see, is that, I feel like I'm missing something, parallelogram, which I think I'm actually going to start with now that I'm talking and writing here. I'm going to start with this, and then we'll go rectangle. So let's talk about properties of parallelograms, and then we'll talk about parallelograms themselves, rectangles, rhombuses, squares, and then we'll come back and talk about kites and trapezoids. Okay. I have a Geogebra file here. Oops. Excuse me, wrong one. Right here, it's called Special Quads Tool, and we're gonna refer to this quite a bit. You'll use this as a tool to help us quickly construct special quads. So what I did was I made some custom tools here. Each of these, notice there's 7 tools. Each of these are one of our special quadrilaterals, and also below, when you hover over, it tells you how to use the special quadrilateral. And all you're gonna do is put some points down, and it'll make it. So since we're talking about a parallelogram, I'm going to click on my parallelogram custom tool here, and I'm just going to place some points, and notice it makes a parallelogram, and it has our definition of the parallelogram illustrated. So we have these arrows showing parallel, so we have 2 pairs of parallel sides. It's a quadrilateral, right? So as long as this, no matter what we do with our vertices, it'll make a parallelogram. Okay, let's check our properties here and see if we got some stuff going on. In our construction before, we took a triangle, like this one, and we reflected it over this diagonal side, right? And it made, oops, weird. That was our rhombus, wasn't it? Not our parallelogram construction. My bad, I'm going to go back here. So if it's not a reflection, it seems to me that this side here is congruent to this side here, right? And let's try to illustrate that even further, maybe. There, yeah. This orange side looks like it's congruent to this side here. So, and this side looks like this, you know, these green and blue sides are congruent to each other. So a reflection, that makes sense. A reflection shouldn't work, right? It kind of looks like we need to rotate this. This side needs to rotate up to here. This side needs to rotate down to here. This side would kind of rotate on itself, which implies then if it rotates on itself, then it must be on the angle, or the angle of the center of rotation must be on that side, right? So let's do that 180 rotation. I'm going to grab my midpoint tool, and I'm just going to click on this segment, and it just makes the midpoint of the segment. You could click between A and C, click A, then C, and it'll also give you that midpoint between them. Either way, now I'm going to grab my rotate tool, because it seems like a rotation. Rotate 180 degrees. Okay, that makes sense. So I'm going to keep these here, these polygons. I'll just shade them differently, so that we know that they're congruent. And let's talk about some things here. So notice I said before, this looks like the orange and this brown segment are congruent to each other. Looks like helps us get to the actual relationship. It doesn't verify. Just because we say it looks like, it's not good enough. So looks like, though, helps us kind of get to the point where we can say that these actually are. Let's prove that these are. So if this is a rotation, then didn't this segment just rotate to this segment? And for right now, that's going to be our reasoning for it, right? So due to rotation, segment AB just rotated to this segment over here. We won't call it AB. So this side has to be congruent to this side because it just rotated here, right? They have to be the same length. Okay, this green segment just rotated up to this blue one, so that has to be the same length. So in a parallelogram, it looks to me like these opposite sides, not only are they parallel to each other, but they're going to be congruent to each other, right? So that's a property no matter what. Let's I'm going to move these pen strokes here. No matter what our parallelogram looks like, I hope that you can understand that reasoning, that this side, no matter what, is going to rotate to this side, no matter what our parallelogram looks like. So they're always going to be the same. And same with the green and blue. So in our parallelogram here, let's say that opposite sides, so we're going to list properties, opposite sides are congruent. Okay, there's one property. Okay, let's go back and let's look at another kind of investigation. Let's use that rotation concept to do some other reasoning. If this triangle rotated to this triangle here, then this angle, if it rotates 180 degrees, must rotate exactly to this angle. Okay? Now, it's hard to see that, this angle of the, let me get rid of these here, of our actual parallelogram, this angle here, the way that I have this set up, it's kind of hard to reason rotation of this whole angle because it's split, right? This whole angle is made up of this angle and this angle. Same deal here and here. But let's argue that this angle has to be the same as this. And again, please follow the logic here, because again, this is logic and trying to illustrate how we can reason some things for later. Let's use the fact that in a parallelogram, opposite sides are parallel, right? So these are parallel to each other. And here's a transversal. Oops, looks like I missed something. Okay, there's our transversal, right? So I'm going to even hide my polygons here. So we have this two parallel sides in a transversal relationship. So I hope it makes sense to you that this angle right here and this angle right here have to be the same because they're alternate interior angles. Okay, this angle here and this angle here have to be the same because they're alternate interior angles. Okay, so does it make sense to you that if we take this angle plus this angle, it makes the whole angle? And we're adding the same two pieces here, right? Just a different order, but they're the same two angle measures, and they make this angle. So doesn't this angle here have to be the same as this angle? So these opposite angles, that's what we're going to call them, are opposite. They're angles that are across from each other, right? Just as these are across from each other. Across implies opposite. So what we're going to say in our properties is that opposite sides are congruent. Not only that, but opposite angles are congruent. Okay? What else can we reason with parallelograms here? Okay? So I'm going to get rid of my pen strokes for now. I'll just hide them. Back to our parallelogram. Maybe I'll get rid of those lines now that I'm done showing the parallel relationship here. What else can we talk about? And let's go back to that congruent concept. I'm going to put my polygons back up here. So here's our diagonal. We rotated this reddish triangle to this blue one. What if we drew in that other diagonal right now? Maybe this one. Let's take a look at our diagonals. Since we rotated I hope it makes sense to you that this length right here, if you think about this black diagonal, this one right here, isn't this length right here the same as this length right here? Because didn't segment EB in this case just rotate to make this segment E B prime or D, if we want to call this an ABCD? Isn't this segment the same length as this? So if this segment is congruent to this segment, it must be too. I wonder if this segment here, this half of this diagonal, is congruent to this half. Well, if you think about this lower triangle here, instead of thinking of a rotation around this point on this diagonal, we could think about this as the midpoint of this diagonal. Isn't it this the midpoint because its distance E to B is the same as E to D, because those segments are the same? That would be the midpoint of this segment as well. So both of these diagonals, it looks like, get bisected, right? Cut into two equal parts, right? Two equal parts. This half is equal to this half, or congruent to that half, and this half of the diagonal is congruent to this half of the diagonal, aka they got bisected. Okay, so that's going to be another property that we're going to talk about here, is that the diagonals are bisected. Okay, both of them are. So we should write here both diagonals are bisected, cut in half, and we'll just make sure we understand that, right? They intersect, both diagonals intersect at the midpoint of both diagonals. Okay, that's what the bisect means there. Alright, so that seems to be a property that will always kind of hold true. I hope you can follow along with that one, no matter what our parallelogram looks like. Then this diagonal, or half, is congruent to this half is congruent to this half, right? Okay. What else could we talk about? Angles, we got diagonals, we got sides. I think that's about it that we can kind of look at when we talk about this rotation. Okay, so using the symmetry concept, this rotational symmetry in a parallelogram, we can actually argue some properties, and I hope that these make a little more sense than if I were to just give them to you. You can kind of see that. Okay, so I'm going to give you the attempt to use this special quadrilateral tool app to think about some of the properties. Have you list what you think are properties of our other special quadrilaterals. Now here's one thing to think about. Our flow chart, that since a rectangle, for example, a square, a rhombus, those are all parallelograms, then they're going to have parallelogram features, right? So even if I make this thing, say, a rectangle, try to make that 90 degrees, the diagonals are still bisected, the opposite sides are still congruent to each other, right? The opposite angles are still congruent to each other. This angle is 90, this is 90, that 90 rotated to make this 90, and this 90 degree angle could rotate, you know, around that point to make this 90. So opposite angles are still congruent. So being a parallelogram, like a rectangle is a parallelogram, a rhombus is a parallelogram, and a square is a parallelogram, then those three additional special quads have these parallelogram properties as well. So when I'm asking you to list the properties of, say, a square or a rectangle, we automatically get the same properties as a parallelogram because they are parallelograms. So please understand that concept. So when you're listing out rectangle properties, we have the parallelogram properties as well, but because a rectangle is a special parallelogram, there might be some additional properties specific to just a rectangle, or specific to a square, or specific to a rhombus. Okay, so with a little guidance through your submission files, I want you to find the properties, some additional properties of our special quadrilaterals. Okay, so good luck, guys.